For this lesson, we're going to be talking about inverse variation. Inverse variation creates a constant k when your two variables are multiplied. So if your constant stays the same, the change has to come in x and y. So as one gets smaller, the other one gets larger. So if two sets of points are inversely proportional, first let's define our 2 points, x1, y1, and x2, y2. And if they're inversely proportional, then you would multiply the two and set them equal. Now we learned earlier about direct proportion, and a way to keep these straight is to think about direct divides, inverse multiplies. Now joint variation is multiple direct variations. So if it says that one variable varies directly as and names two other things, then you would divide both of those. So you're going to divide with direct and divide with joint, but multiply with inverse. So for our first example, if y varies inversely as q, so my setup, y times q. So it's an inverse, so we're going to multiply. So that means 22 times 6 equals 15 times q. And 22 times 6 is 132 equals 15q. And then we divide both sides by 15. And q is 8.8. Now let's look at example 2. This example is a joint variation and an inverse. There's a combination. So the first one that's listed, the r, right here, that's always the numerator. So we're going to write the r down. And everything else is in relationship to r. So jointly is s and t. So s and t both divide. And inversely is u, so that multiplied. So that's how we're going to set this up. So we're just going to plug in. R is 18, S is 2, T is 3, and U is 4. I'm going to set up the other relationship. U is 4. No, that's the other one. Find S, so we want to look for S. When R is 6, T is 2, and U is 4. Okay. Well, this is easier to do. If we go ahead and cancel, you can certainly multiply it all out and then solve for S, but I like to reduce as much as possible. So 2 goes into 4 2 times, 3 goes into 18 6 times, and 2 goes into 4 2 times. So then we can simplify, and this gives us 12 is equal to 12 over S. That gives us 12S is equal to 12, and S is equal to 1. And that's our answer. Let's look at the next example. The next example, time required to travel a distance is inverse. So inverse means we multiply. So time and distance, time and speed, speed. Okay, so a trip can be made in 3.6 hours. That means 3.6 is my t, and I'm multiply that by 70. And how long is what we're looking for. So it means I'm looking for t, and so my s will be 90. And when I multiply 3.6 times 70, I get 252 equals 90 t, and that gives me 2.8 hours. And yeah, you do really need to use the unit. Okay, for our last example, we're looking for cones of equal volume. So the volume would be constant. And it says the height, h, is inversely proportional, so we're multiplying, to the square of the base. So really that is square of the radius of the base. Inversely proportional, so it means we're going to multiply. So there we go. And it says if the radius of a cone is 10 centimeters, so we can square that, and its height is 15, find the radius, r squared, for the height of 60. Well, okay, so let's multiply. So we're going to have 1500 equals 60r squared, and we need to divide, and that gives us 25 is equal to r squared. We want r, not r squared, so then 5 centimeters is my radius. And that is inverse and direct proportion and joint